Okay, CL7-121 asks us to simplify and solve the following equations. Well, this first equation is very straightforward. There are no portions, no fractions, no decimals or anything. So we're just going to use our basic problem-solving skills to solve these equations. My strategy, it looks like, is I'm going to go ahead and combine the like terms, but actually there are none on each side. So really I'm just going to get the variables on one side. And to do that, I think I'm going to go ahead and add 3x to both sides. 3x. Okay, and when I do that, I end up with 8x plus 2 equals, this cancels out, negative 14. Okay, and I'm going to go ahead and get the constants on both sides. So to get rid of this plus 2, I'm going to subtract 2 minus 2. And notice I'm subtracting 2. That's because I'm really just trying to get the variables on one side, the constant or the numbers on the other side. When I do that, I have 8x equals negative 16. And finally, I'm just going to go ahead and divide by 8. Divide by 8. Okay, and x negative 16 divided by 8 is going to be negative 2. Okay, number 2 does have a fraction. Number 2 gives us 2/3 x plus 1 equals x minus 4. Okay, so there's a few different ways we could solve this. I think to get rid of the fraction right away, what I can do is I could just go ahead and multiply everything by 3. Okay, we're going to go ahead and use the undoing division. So let me actually go ahead and just rewrite the whole equation. Okay, I could go ahead and just get rid of the fraction right away by multiplying both sides by 3, and I'll go ahead and do that. Okay, and when I do that, I'm going to distribute that 3. Distribute the 3. Okay, 3 times 2/3 is going to be 6 over 3. X plus 3 times 1 is 3 equals 3 times x is 3x. And then 3 times negative 4, or we could just subtract, 3 times 4 is 12. Okay, now we just end up with 6/3, which is just 2x plus 3 equals 3x minus 12. And just like before, I'm going to try to get the variables on one side, constants on the other side. I notice here there are 3 x's, so I'm going to move the x's to the right side this time. And let's go ahead and subtract 2x, subtract 2x. And we end up with 3 equals 3x minus 2x is just x minus 12. And I'm going to go ahead to get rid of this minus 12 because I want the x by itself. I'm going to add x, add 12, and I end up with x equals 15, or 15 equals x, I should have said. Okay. For number 3, again, it looks like we're going to go ahead and we have some decimals, some portions. Okay, well, I guess the question now is, what strategies can I use to get rid of these portions? And I think what I'm going to go ahead and do is I'm going to actually multiply to get rid of the decimals. I'm going to multiply the place values, and since this is in the hundredths place, I'm actually going to multiply by 100. Okay, I'm going to multiply by 100. There's a few different ways to do this, but I think just because of the situation we have with the decimals, I'll go ahead and multiply by 100. I don't think it's the easiest, but I think that's the easiest to understand if we're a little stuck on this. Okay, so once again, I'm going to go ahead and start by rewriting this whole equation. 5/10 x minus 5/10 equals 75/100 x plus 1 minus x. And actually, now that I think about it, I'm looking at it, we can actually combine the like terms. I'm actually going to combine the 0 and 75x with the negative x right there. Okay, so I'm going to keep everything else the same. 5/10 x minus 5/10 equals 75/100 minus x is going to be negative 0 and 25/100 x plus 1. Okay. Now, okay, we have a few options. We can do what I said before, multiply both sides by 100 to get rid of the decimals. We can even convert it to fractions, which actually might be easier. Or we could continue combining like terms, moving the decimals to one side and the constants to the other side. So we have 3 different methods we could do. I'm going to go ahead and, because I initially said I'm going to get rid of the decimals, I'm going to multiply both sides by 100. Okay, if I only multiply by 10, this will still be a decimal, so that's why I'm multiplying by 100. Okay. Okay, that being said, now I'm going to distribute the 100 times 5 tenths. Really, we just move the decimal over 2 places, right? So that's going to be 50x minus 50. Okay, 5 tenths times 100 is 50. Equals 100 times negative 25 hundredths is going to be negative 25x. 100 times 1 is 100. Okay, now that the decimals are gone, it might be easier, and we're going to go ahead and just move the variables to one side, constants on the other. And to do that, I'm going to add 25x. 25x. Okay. 50x plus 25x is 75x. Minus 50 equals, this cancels out, 100. I'm going to add, oops, let me do in red just so we see it. I'm going to add 50 to both sides. Okay, so we have 75x, this cancels out, equals 150, and we could go ahead and divide by 75. So we're finally going to get, well, 150 divided by 75 is 2. So x equals 2. Okay, in this last problem we're given, it doesn't look like we have any portions, so I think this might be a little simpler, but we'll see. Okay, I think what I'm going to do first is go ahead and combine the like terms. Okay, 5x minus 2x, okay, is just 3x, and then we have the plus 6 equals 3x minus 7. Okay, what do you notice? Well, I'm noticing that there are the same number of x's on both sides. However, the constants are different. The constants are different. We have 6 and negative 7 here, which means that whatever x equals, it's never going to be a true value, because let's say we try to solve this. We're going to subtract 3x minus 3x. That's saying that 6 equals negative 7, and that's never, ever, ever true. So what does that mean? Well, that means there is no solution.